This webinar is brought to you by Provectus. We're gonna make a more detailed intro, but we are technology consulting partner and AI solutions provider. A few notes before we begin. As we move through the content, you're very welcome to post questions in the GoToWebinar chat tab on your right. And we will address those questions during our Q&A session at the end. And we will also provide you a webinar recording and all the useful links shortly after the session. Happy to see people are joining, and in the meantime, we're gonna get started. So a lot of MLOps content nowadays is focused on tools or infrastructure, and people aspect is missing. So in our webinar, we would like to start with the first part of our cocktail, people. ML engineers, data scientists, DevOps, MLOps, and other roles to build a highly productive AI team. Secondly, then we will map those roles to the actual infrastructure that supports the most productive AI teams in the industry. And the second part of the cocktail will be mixed from the various tools and cloud services to support those operations. Finally, we will discuss how Provectus can accelerate your AI/ML journey by making your citizen data scientists to iterate fast and reliably. So please stay with us till the end and learn how to get qualified for a fully funded management workshop. About Provectus, Provectus is an AI solutions provider and technology consulting company with competencies in machine learning, big data, DevOps, and MLOps. We're headquartered in Silicon Valley with offices in Canada, Latin America, and Europe. Our customers range from cutting-edge startups to mid-sized and large enterprises who are seeking for innovation through artificial intelligence. We work on hardest problems in the world, like simulating turbulence in supernova explosion using deep learning models, as well as on some applied AI solutions, for example, demand forecasting and inventory optimizations for the companies like Blue Bottle Coffee. Unlike other professional services companies, we're an active contributor into the open source machine learning and data infrastructure projects. And this is what enables us to bring the latest and greatest innovation to our customers faster. Quick intro. Here I am, Stepan, Provectus co-founder and CTO, covering R&D, delivery, and solution architecture. I'm happy to co-present with Rinat and Linar. Could you guys introduce yourself? Hey, Rinat.
Yep, sure. Yeah, hello, my name is Leonard Abdrahmanov, and I am machine learning engineer at Provectus. And today I will be helping you with your questions. Please ask your questions in the chat or in the question tab. Thank you.
Yeah, probably Rinat has some issues with the connection. So Rinat is our senior machine learning solutions architect based here in San Francisco. Yeah, we have introduced yourself, and it would be great to learn more about the audience. What's your role? I'm going to run a quick poll, so I will see who is in the room and better tailor my narrative to address your needs and role. Launching poll. Please take few seconds to answer. I believe that's the easiest question we can ask. Yeah, about half of the audience has voted. few more seconds. Yeah. Apologize if your role is not listed here. That webinar intentionally was for the ML practitioners and kind of hands-on managers who is deeply involved in the industry, but you can skip the poll if you are not from those roles. Okay, I'm closing the poll. So now you can see the results. I apologize, I cannot see the results, but yeah, here we go. So we have a good mix of data scientists and machine learning engineers, as well as infrastructure. Yeah, so here are the poll results. Good mix of data scientists, machine learning engineers, and majority of people are from infrastructure, which is interesting. Thanks for joining, and yeah, happy to guide you through the content. So let's jump in. I want to use a real-world case study to visualize a North Star in terms of the people, infrastructure, and processes. Basically, the right MLOps cocktails required to execute the AI project end-to-end. GoCheck Kids is a Provectus customer and is an amazing company that helps millions of kids to prevent vision impairment. And the Provectus and GoCheck Kids have been working on the problem of reducing manual overhead during child vision screening. The team of ophthalmologists had to review more than 50,000 images per month, which was costly and inefficient in the long run. And inaccurate image processing also caused readmissions, which not only added up to like 20% of the overhead cost, but also negatively impacted customer satisfaction. So with this in mind, the primary goal of the GoCheck Kids team was to improve the accuracy of the application, of the application's automated image processing. And as you can imagine, security and compliance was the first priority for this type of the customers and the use case, for the obvious reasons. We have framed the machine learning problem as an end-to-end classification to detect child gaze, strabismus, crescent, and dark iris people population. That's the context, and obviously just to solve this problem, it is not enough to just to hire a data scientist and to deliver this project from the beginning to the end. The balanced AI team, balanced and cross-functional AI team has more than one data scientist. And in this particular case, we had a group of subject matter experts because it's just such a niche domain that requires the addition, like many years of experience. And in this case, basically, it was a group of ophthalmologists contributing to the project on a daily basis. Data scientists own and understand the data and business holistically. They're on top of the data quality and data bias issues. They analyze experiments, model outputs. Data scientists validate hypotheses and contribute into the machine learning engineering roadmap. And at the same time, machine learning engineer role and skill set is different from data scientist role. First of all, machine learning engineer should have a deep expertise in particular machine learning or deep learning use case. In this project, it was a computer vision specifically. So obviously, it is hard to imagine that data science generalist may have a deep knowledge in state-of-the-art deep learning models for computer vision. Any machine learning engineer should have an MLOps expertise. However, an MLOps infrastructure itself, tools and components should be owned by dedicated MLOps specialists. We'll talk about this in details later. Project manager should be also trained to execute ML and AI projects. This is a different topic, but I'm going to give you a quick heads up that Scrum, like traditional Scrum or Kanban project workflows, does not work for a machine learning world. In Provectus, we have a methodology for managing scope, timeline, setting expectations of the business stakeholder specifically for machine learning projects. And again, we're visualizing a North Star on a particular case study. So for this team, this size of the team, and the proper infrastructure which powered that team, we conducted about 100 experiments on entire data set within just 3 weeks as we started the actual execution. The data set was quite big. It was 100,000 of images, and each experiment took us from 15 to 6 hours on a single GPU. So by experiment, we mean tracked end-to-end experiment on a cluster. We're not counting development runs and.
Stepan?
Oh,
I'm sorry. Yeah, you should close the poll. The audience doesn't see slides. Yeah,
oh.
you should push the button and return to slides.
1 second. Sorry, guys. How can I do that? The poll looks closed on my side. It looks like a glitch. The go to webinar, hide results. Can you see the screen now?
Not yet.
So the poll, the poll is closed.
Can you relaunch screen sharing, Stepan?
Yeah, 1 second. Just relaunched. Okay, I see that the. Wow, that's. Let me stop showing the screen and then relaunch it again. Wow, that's a huge issue. Okay, so I see the screen is sharing now. Apologize for that. I believe we should use a different platform next time for that. But yeah, just for the purpose of the quick recap, let me show you the slides that I missed. So we started talking about the GoCheck case study as a North Star to visualize the kind of how ideally AI teams with a proper infrastructure should perform. We went through the business problem and the actual solution. That's the team composition that we have, that consists from subject matter expert, data scientist, machine learning expert, cloud and security specialist, full stack engineer, project manager for machine learning, and MLOps specialist here. With this team and the proper infrastructure that we're going to be talking about in details, these are like team velocity results that could not be achieved without the infrastructure itself, and of course without the clear separation of roles and responsibilities here. It's important to know that while running one experiment, it was really important to move forward and run experiments for the next hypothesis. So, and since data pre-processing took about 5 hours, we had to version output data sets and reuse them in upstream pipelines. Security-wise, we had to minimize the access to the real data for machine learning engineers, and most of the full-scale experiments were run in a blind mode, when machine learning engineer works with metrics only and reports on probably some logs without touching the actual raw images. Here is a result summary. So we have improved the recall of the original computer vision based image processing algorithm by 3x. And one of the major achievements was that machine learning engineers and data scientists were focused on modeling and experimentation rather than fighting with the infrastructure and data preparation. The main message here, this could not be possible without balanced team composition and MLOps foundation. And with this like North Star in mind, let's move forward with some implementation and some practical tips for you guys. Although we don't have a lot of managers on the call, but I want to start with the management challenges, because every company is not only from tools but also from people, and very often, especially in enterprises, the kind of existing org structure just prevents from building end-to-end machine learning projects. So here we go. You see a typical org structure with business units. Traditional software engineers report to VP of engineering. DevOps and infrastructure experts report to VP of infrastructure. And group of data scientists who usually work directly with business stakeholders. They bind the data and provide some insights for those business stakeholders. Usually there is a separate data engineering group, but I think you get the point I'm trying to make here. So the first challenge is that companies have a limited understanding of machine learning workflow and AI project management. Nobody from those groups can fully understand how to start with a business goal and then launch an AI product in production. And as a result, it is impossible to manage AI project scope and KPIs, and that leads to the missed expectations from the business stakeholders. Some companies try to delegate AI projects to existing data science teams who historically were working in its own silo and have been using completely different data science approach that is not equal to machine learning. On the other hand, other companies tend to assign AI projects to traditional like Java or .NET developers or leverage third-party machine learning APIs. This approach tend to fail again because you still need a deep understanding of the data and underlying algorithms to use those APIs. And as a result, we see a growing technical debt in the form of data science code that will never see the production. The solution, as you can figure out from the previous slide in the intro, the team and the infrastructure. Let's see how the high-level infrastructure and maps to the actual roles that we have in the team. So on the bottom, you see the MLOps backbone, which is like networking and some baseline server like access, networking, security, and CI/CD pipelines. On top of that, there is a shared and reused assets like notebooks, and there are pretty much a lot of things like images, kernels, and notebook templates itself that could be shared and reused across different teams and different projects. We'll also treat pipelines, machine learning pipelines with its components and libraries as an asset to be shared, experiments as well, and data sets and features that can accelerate and actually standardize the machine learning operations and development cycles. Models itself is a good asset to be reused and versioned across the different teams and different stakeholders here, different roles. And having this foundation, there are AI projects that you can execute kind of independently from that foundation. Let's see how it maps to the roles. Cloud and security, obviously owning the backbone and also contributing to the MLOps infrastructure. ML engineer, as I mentioned, should have a skill set of MLOps expertise, as well as he's usually an active contributor into the projects. And MLOps specialist, again, working hand in hand with a machine learning engineer, but he basically owns that infrastructure. It could be like a SageMaker, it could be Kubeflow, it could be any other components, but there should be a person who sticks things together and owns the service layer. Citizen data scientist is focused on just an implementation of the particular projects and checking the hypothesis, providing the results, and sometimes, not sometimes, in most of the cases, he owns a particular part of the machine learning pipeline. We're working primarily in notebooks in this case. So we are not trying to kind of get citizen data scientist out of his comfort zone and make him to learn MLOps infrastructure and so on and so forth. And as any ML project is the same software, the end product should have the services, the APIs, the UI, and the full stack engineers, and the project management are the essential part of the team that are working on the actual implementations. So hope this makes sense to you, and I'm gonna move to some MLOps infrastructure implementation options. Again, so there are a few things to consider before we dive into the actual demo and the details. There is an option to build it in-house using open source. We have full control, but unless you are the Google of the world and Facebook of the world, I believe it's just has the highest TCO and time to market. So please consider this option thoughtfully and with adopt. You can there is the second option is rely on a cloud vendor, fully rely on a cloud vendor and just use all the greatest greatest tools, which is a good option. It depends on your cloud strategy, and for many companies it is recommended. It has lowest TCO, quickest time to market. It has some vendor lock, but many companies are very fine with that, okay with that. But however, there is a common misunderstanding. It still requires some heavy lifting. You cannot just hire a data scientist and open an access to SageMaker and here you go. It's not going to work this way. You still need to have an MLOps. You still need to have an involvement of the cloud and networking people from your organization. And the third option, which is mostly preferred for the tech enterprises with a multi-cloud strategy, who wants to own the kind of the core, the backbone, and use services and compose services as they want. It could be an open source, it could be a third party, it could be cloud native services, and it still has relatively low TCO because you're not reinventing the wheel here. You're owning the backbone, kind of you're the brain of the platform. And it is highly extensible, may cover the use cases that are not common for others. Here I want to give the word to Rinat, and so we can dive deeper into the reference architecture and the implementation options.
Yeah, thank you, Stepan. Hi, everyone. Sorry for previous trouble. So let me share my screen. I will. Okay, so yeah, so let's take a look how this might be implemented in practice. So in this diagram, we depicted like high-level constituents of machine learning infrastructure. Yeah, so on the bottom end, you can see experimentation environment, which primary goal is to produce model, like model package that can later be used in production environment to make some actual prediction. And there's also like CI workflow, continuous deployment workflow. Yeah, let's see how like different roles fit into this architecture. Wait. I'm sorry, guys, it was my girl. Yeah, sorry for that. So data scientists usually work with raw data, perform data analysis, usually in notebooks, like find different patterns, check different modeling hypotheses. And there are several benefits that like the experimentation environment and machine learning infrastructure can like bring to them. So we can use reuse existing components to avoid writing everything from scratch, like features or like data transformation. We can also use can automate tedious and error-prone tasks like running experiments pipelines from end to end. Yeah, and they can also include experimentation environment can also contain like pre-configured data access patterns, which can be useful like from security perspective. Yeah, let's move to next role. Machine learning engineers like do several things. So first of all, they productionize models, meaning that they prepare algorithm code, data preprocessing code to be servable in production environment. And they also like automate, like develop these model training pipelines for the experimentation environment. And as you can see, there are like different types of assets in this workflow, like data, code, models, like different environments. And this means that DevOps or infrastructure engineers can help with managing all these assets in an efficient way. For example, here numbers show steps of CI workflow that is triggered by like some hook in Git repository, like for example commit. So it can work like the following way. It will like build old code artifacts like Docker images, and then run model training pipeline, perform some checks on this model, and if it's okay, it can push like model this new model version into production environment. Okay, so yeah, this is like example implementation using Amazon SageMaker. So SageMaker is a fully managed service that provides a set of tools that can cover like almost all of steps of a machine learning lifecycle. Yeah, so and here we use it just for following purposes. So first, we use like SageMaker processing jobs for different data processing tasks. For example, on the right, we can use it to perform evaluation. We use SageMaker Feature Store. We use SageMaker training jobs to like offload heavy training. Yeah, and also, sorry, we use like SageMaker ML lineage tracking, and like it's called SageMaker experiments, just to track different versions of like artifacts, like data sets, models, via metrics, and so on. Okay, and in production environment, we can use SageMaker real-time endpoints to serve like data preprocessing and model predictions in real time. Yeah, so the important thing to note that you can use SageMaker components in conjunction with each other, or you can pick only those that you miss in your infrastructure. So for example, here we use SageMaker pipelines as a pipeline orchestrator, but it can be replaced by like open source alternatives like Kubeflow pipelines, for example. Yeah, this said, let's move to like live demo. So before I will share, so just brief definition of machine learning task itself. So just predicting delays of airline flight, and here we use like publicly available data from US BTS, and its pre-aggregated version that is published on Kaggle. So let me now go to SageMaker Studio, and I will show you how. Yeah, let's start. So here you can see training pipeline. So this is the SageMaker Studio, and it has nice user interface to visualize pipeline graphs and the execution metrics and so on. Okay, so here you can see just pipeline definition. If you go into some like execution, yeah, so you can see it's not that simple. So just briefly mentioning, so it starts like preparing data, splitting into the different like training, validation, test parts, extracting like target variables, extracting features, yeah, applying all of this for different parts. Yeah, I've also used here SageMaker head parameter tuning, and then we use best model to like perform evaluation on the test part. So this is probably like very well known for all like data scientists and machine learning engineers. So yeah, and also the end result of this pipeline, it should be a model package that can be later used for different purposes. So the main one is to serve it in production environment, and for that we use here SageMaker model registry. So we can see, for example, if we go here and SageMaker part of AWS console, here we can see all these different model versions created by pipelines. So yeah, and so SageMaker model basically represents like code defined as a Docker container and some artifacts that was produced during training. Yeah, so just combination of these two. And yeah, so as you can see, it's like completely independent of like infrastructure that will be used for production. So it's like kind of abstraction, convenient abstraction to like separate concerns between machine learning engineers and infrastructure engineers. So and how can we use it? For example, if I open inference pipeline, so here it means that we want to produce like predictions in batch mode. So like, for example, daily, and it is very simple. So we can use SageMaker batch transform, which just takes model produced by training pipeline and apply it for data. And we just reuse this step. It's called featureized inference data. So it's basically the same component that was used in the training pipeline. Yeah, and yeah, this is about pipelines. And also we have like for other use case, if you want real-time predictions, we can just you create real-time endpoint using the same model package. Okay, and very quickly, so here about continuous integration part, we use here GitLab CI to like automatically build all components and deploy like changes in pipeline. So there's two big jobs here, like for each commit. As you previously seen, there are like quite a few steps. They all defined, well, except built-in steps, all others are defined using like Docker images. So here we can automatically build these Docker images and just produce new pipeline definition that refer to this new like code artifacts and the versions. Yeah, and just as an example, there's also like kubeflow implementation of the same pipeline and basically reusing the same code for components. So yeah, let's open the example. Yeah. Here. So it's a little bit different because the kubeflow pipelines and SageMaker pipelines works with data artifacts a little differently. For example, in kubeflow, you don't have you can work with other data sources, not only with S3. Yeah, so that's why there are some like auxiliary steps that help to make it the same pipeline. But what's important here that like Docker images remain the same. So we reuse the same Docker images between like SageMaker pipelines version and kubeflow pipelines version. So with this being said, I guess yeah, I will return to slides now.
Yeah, I believe the main reason, just to clarify for the audience, the main reason we're showing the two different implementations of the same reference architecture is to highlight the fact that it may really depend on your strategy and preferences. For instance, if you have already heavily invested into the Kubernetes infrastructure, you may want to stick with that. If you are all in like Azure or AWS, or that's also an option, and the actual reference architecture, the workflow will remain the same, and the principle that you owe as an enterprise, you owning the code, the business logic, the models, but delegating, offloading, the heavy lifting processes like training, hyperparameters tuning, distributed training. You don't want to reinvent the wheel and just build it from scratch, or even managing it on Kubernetes or kind of it's very painful. So this area is getting more and more commoditized by cloud providers. Yeah, we also wanted to kind of answer some frequently asked questions. If you and with this next slide, I'm gonna be asking questions, and Rinat will try to elaborate on the answers. This is what we typically see, some concerns from the data scientists. Why can't I build everything in notebooks, and why do we need so much complexity, components, CI/CD, and basically just so many files. Can you elaborate on this, Rinat?
Yeah, so basically for us, like we can group all the issues that notebooks lead to into like several groups. So first, like reproducibility. So notebooks are stateful and they can contain some hidden implicit state, and there's also complications that can be with execution order. So all of that might lead to like reproducibility issues. So you can achieve like good evaluation metrics, but it can be then later hard to reproduce, and especially for other team members. If you made some assumptions but haven't like documented them explicitly. Yeah, the next type of issues is scalability. So for example, notebooks are bad for running long asynchronous tasks. It would be just hard to monitor them from outside, or like automatically run some failed steps and so on. Yeah, the next category is like parameterization issues. Notebooks like provoke to use very bad pattern, like to clone them, copy paste, change, and launch. So, and also the last one, it's like notebooks promote like many other bad engineering practices. So first of all, they are like monolithic, so it means like hard to test, hard to change, and hard to collaborate. And there is also like no contracts between workload steps, hard to check like new hypotheses like without copy pasting or like writing from scratch, and also hard to manage by DevOps, MLOps, like infrastructure engineer. So hard to add continuous integration or continuous deployment workflows on top of it. Yeah, so I guess this is it for that question.
Yeah, but I believe, let's have them. Let me play an evil advocate on this. But I believe it's quite crucial to have notebooks anyway. We're not against the notebooks, and they are pretty useful for many purposes. And if we talk about citizen data scientist, he should have an interface, a good interface to interactively work with data.
Yeah, so
sounds good. So I think there is a common misunderstanding, and there are different opinions. What is the actual machine learning model?
Okay, so yeah, this question is caused by like different understanding of this concept by different roles in AI ML team. For example, data scientists usually produce a model as a bunch of like algorithm code that is proven to be effective via evaluation on some fixed data set. But it's not something that is usually expected in production environments. So there have to be means to integrate it with actual product and end users. So with few simplifications, like we can say that for machine learning engineers, an MLOps model is much more. It's like code of algorithm plus code of its integration plus like model artifacts, like model weights produced some by like training, and plus code for initializing that model, meaning how to like feed these model artifacts into model code to make it ready for predictions. So, and furthermore, like this code, like in production environments, it requires some infrastructure to be executed. So quite, it leads to some very frequent misconception here. Like model is not the same as its endpoint. So simply saying we can make it this way, like endpoint equals like model plus infrastructure. So, but quite often these concepts like mixed. So it's important to make agreements inside the team and organization before. So what is considered to be model? What should be delivered by different team members? Yeah.
Sounds good. Yeah, there is also the notion of the ML pipelines that which is now frequently like very often considered as a machine learning model itself, and I think it's quite useful understanding. So the pipeline, you have demonstrated the pipeline, and which has how many, like 10 steps, 15 steps, and this tutorial of the and this machine learning project can be solved with 100 lines of just lines of code in the same notebook. And can it be simplified in your opinion, in your practice?
Yeah, so it's a good question. We hear it quite often. So if we talk about like development time here, so here's what I can say. Like enabling pipelines has some learning curve and requires additional resources to bootstrap, but it will pay for itself soon because like it enables collaboration, like distributing the efforts for different pipeline steps between like different team members, like also separating concerns like between data scientists, machine learning engineers, and infrastructure engineers, and also like pipelining this workflow. It creates like clear inventory for like DevOps guys to be managed later. So this is something that I already touched briefly when I explained disadvantages of notebooks. So, but once you start using machine learning pipelines, you'll have quite a few components that are like problem agnostic, like or model agnostic. It can be reused for future projects. Yeah. So, and there are there's another aspect of this question. So, like execution time. So, yeah, I agree. It might be like less efficient, like for some kind of hackathon-like random experimentation. But once it's over, you usually plan your experimentation and hypothesis to check ahead. And in this case, it's not that important because just while like pipeline is executing, maybe like several instances of pipeline are executing, you can start working on the next task.
Yeah, basically productivity, there is some it's ramping up, and as you see, like in a couple of weeks, once the infrastructure and the pipelines are being established, it's just pays for itself. Yeah, thank you. What next do we have?
Yeah, I believe we can skip this question because we don't have much time left.
Oh yeah, we have 10 minutes, but I can really spend 30 seconds. We value all other services, and I think they're great, like weights and biases, DVC, and each component of this reference architecture could be, as we mentioned, you can mix and match. You can we can use weights and biases instead of like SageMaker experiments to track your experiments. But if you like it, if the user experience and the capabilities are kind of suit better your needs. So they all evolve very rapidly, and the market itself is quite wild. That's why we our main message is to have that core backbone owned by your enterprise, and then you can really compose different tools as they evolve. Let's briefly talk about how to get started. And so we have our MLOps acceleration program designed by Provectus. And if you move to the next slide, it basically provides you a jump start with your MLOps infrastructure. And as we learned, it is the MLOps infrastructure itself and people and processes, basically a highly productive AI team that may kind of may work with your enterprise and with your stakeholders, existing experts to make it happen. Basically, we kind of, it's a combination of the management, cultural things, and really tangible accelerators in the form of the blueprints. So we usually how it works, we schedule a 30 minutes pre-assessment session with you and your management to see if you're to validate if your problems and needs match our value proposition. If there is a perfect fit, we're happy to move forward and fully fund the first workshop that aims to define the North Star in terms of the different infrastructure options that we have discussed, and also a necessary adoption roadmap to achieve that North Star. And basically, usually it also we try to define the first low-hanging fruit to move forward with. Happy to please check a webinar chat window for the MLOps acceleration program link, a registration link. Also, you can check it in our follow-up email, and happy to stay in touch. You can find me at LinkedIn, and me and Rinat at LinkedIn, and as well as in Slack workspace. That the link you also can see in the webinar chat window. Happy to dive deeper into your challenges and discuss any pros and cons of the different tools and aspects that you have. Thanks for attending, and happy to see you again.